What's up, spacers? This is your specialist, the Space Technician. And in this video, we're going to dive deep into the epic challenge of how SpaceX plans to land Starship on Mars. This is going to be awesome. But before we get into it, if you haven't already, be sure to smash that like button down below and subscribe if you want to see more epic space content. Don't forget to ring the bell too, so you never miss a video when I upload. Now, let's get into it. Remember, strapping in is optional, but recommended. Landing Starship on Mars is absolutely essential for SpaceX's future colonization plans. But making it happen is extremely difficult. I mean, we've seen Starship land on Earth, which pushes boundaries as it is. But Mars? Its atmosphere is only 1% the density of Earth's. There's enough atmospheric drag to help slow Starship down some, but nowhere near enough to fully reduce its crazy landing speeds. Yet, despite all that, Elon remains incredibly confident they can stick this landing. He's targeting the first uncrewed red planet touchdown in just 3 years. Yeah, 2027. That's an absurdly short timeline in my opinion. To have a chance at making it work, Starship is going to need some serious improvements in its engine power and flight stability. I mean, we still haven't even seen Starship successfully reach Earth orbit. But check out this Starship variant through the V3. At almost 150 meters tall, it's a full 25% longer than the V2. That extra size goes directly into expanded methane and oxygen propellant tanks, giving it a lot more landing fuel to work with. SpaceX says it'll haul double what Starship does now. We're talking 200 metric tons to orbit, baby! That kind of payload capacity should help rapidly establish a Mars base when the technology is ready. Of course, reaching such ambitious goals means SpaceX has to get better at mass-producing these things efficiently. We're talking Model T levels, aiming to churn out 100 to 300 Starships per year. Building that many advanced super heavy lift launch vehicles is just unheard of today. But you better believe the machines are being tooled up. SpaceX's future factory plans look incredible. Okay. I know why you clicked this video. You want to understand just how SpaceX is actually planning on landing one of these things on Mars. Well, strap in, because we have a lot to cover. Let's start by quickly going over some key orbital mechanics concepts. I know this stuff can make brains melt, but let's power through a quick refresher on some crucial orbital mechanic principles that make this Mars landing possible, or impossible. Now, being in orbit is actually just perpetually falling towards something while missing it. Counterintuitive, right? Stay with me here. Say we want to escape Earth's pole. Gravity is constantly tugging Starship down into lower orbit. So, to climb out of this so-called gravity well, her engines need to accelerate forward and boost speed. But acceleration is easier when you aren't weighed down as much, so ideally we leave mass behind. Enter stage separation. Booster goes home, Starship speeds up, with way lighter tanks to escape orbit. Then, what goes up must come down. Across? Mars gravity will eventually grab a hold of Starship if unchecked, so engines again fire retrograde to scrub speed upon arrival and prevent overshooting into deep space exile. Finally, there's efficiency. Getting more kick from our propellant requires high-performance engines like SpaceX's Raptors. The excellent specific impulse leverages chemical energy and nozzle fluid dynamics to generate huge thrust. Maximizing this rocket equation is key. Whoa, that was dense. Let's catch our breath. But you get the gist. Changing velocity, reducing mass, boosting engine efficiency, these core principles enable Starship to travel between alien worlds. So in summary, very simply, faster is higher. Efficiency is key. Gravity costs fuel. Follow that formula from launch to landing while avoiding all the explosions, and Mars can be ours. Alright, so let's dive into this crazy refueling system SpaceX has dreamed up for Starship. Because let me tell you, it's going to be vital for making these Mars landings feasible. You see, interplanetary travel takes way more fuel than just getting to orbit. Like, way more delta V. After Starship detaches from the booster, those header tanks we talked about will only have enough methane and oxygen propellant for short hops, not for flying millions of miles. So, what's the solution? SpaceX is developing these dedicated tanker variants of Starship. Yeah, mobile gas stations basically. The plan is for a tanker to meet back up with Starship in orbit and transfer over many tons of the good stuff. We're talking multiple refueling launches to completely top up Starship's main tanks before leaving Earth. This isn't just for Mars, by the way. Any practical lunar mission will need topping up too. And not just at the start. SpaceX wants to have propellant depots already waiting in strategic deep space locations when Starship arrives. This includes stashing extra fuel at the Gateway Lunar Outpost to enable reusable round trips to the moon's surface. Amazing. Alright, I know that was super quick, but this video would stretch days if we got into the full details on SpaceX's vision for an interplanetary transport network. The key point is the refueling system will enable each Starship to have enough delta V in the tank to slow down and land on Mars. More on that epic descent coming up. Alright, let's talk logistics. How's Starship actually going to sail all the way to Mars? I hope you took your motion sickness meds because the flight plan is intense. After topping up the tank at the LEO Propellant Depot, Starship first needs to escape Earth's gravitational clutches. This means firing the Raptors to accelerate up to over 11 kilometers per second. Yes, I said kilometers per second. Nearly fast enough to fly to the moon in a few hours. Once safely away from Earth's sphere of influence, Starship can switch off the engines and coast for months on its interplanetary trajectory. But this journey can't just be a straightforward shot at Mars. No. That would be way too easy. With Mars constantly playing hard to get, moving in its own smaller orbit around the Sun, Starship has to enter a precise chase trajectory to match. Then, as it approaches the red planet, Starship executes a blazing fast retropropulsion burn to shed velocity and slip into orbit. After jockeying into position amongst Mars's moons, Starship performs a final deorbit burn, beginning a fiery plunge into the thin Martian atmosphere. And that's when the real fun begins. The epic attempt to shed an unbelievable amount of speed in just minutes to have a chance at sticking the landing. Alright, time for some more rocket science. When approaching Mars, Starship will use some clever tricks to leverage the red planet's atmosphere to help slow down. Now, I know what you're thinking. Mars's atmosphere is only 1% as dense as Earth's. True, but SpaceX plans to utilize every scrap of drag they can scrape up on arrival. They call these maneuvers aero capture, using air resistance for part of the braking instead of solely relying on the rocket engines and fuel. It's actually extremely difficult to nail correctly, but if done properly, this air friction can shave off nearly a kilometer per second of velocity for Starship on arrival. Some of the techniques under consideration include digging deep into upper atmosphere and grazing passes to steadily shed speed with each flyby. We're talking skimming the outer edges here, flying just low enough for some seriously heated turbulence. Doing a lift pass, orienting Starship to maximize drag and actually leverage atmospheric lift to dive even deeper on passes, enabling faster descent towards final landing trajectory. And my personal favorite, the Crazy Ivan. This wild move flips Starship end over end to expose the giant underside and create maximum air resistance, like putting on the space brakes. Add it all together, aerobraking, aero capture, skip maneuvers. It's going to be a white-knuckled guided tour through the Martian skies. But if done right, it should allow Starship to preserve a ton of fuel for the final powered descent and landing burn. Fingers crossed. Now, coming into Mars, Starship has already shed a lot of velocity from its aero capture and orbital dance. but it's still moving at a blistering Mach 5 by the time it reaches the upper atmosphere. From there, it has just minutes to scrub off kilometers per second before auguring into the ground. Yikes. You see, Mars's atmosphere is about 100 times less dense than Earth's at sea level. While the initial friction helps, there's a major problem. Limited thickness means there's not a lot of air passed through on the way down. On Earth, Starship gracefully belly flops for minutes. That's not going to happen here. There will be a much shorter window for the drag to gradually slow it down, and less drag overall means reaching higher terminal velocities. Freefall speeds the air itself can't overcome. Plus, unpredictability is high. Weather patterns, winds, and dust storms on Mars can toss our intrepid Starship around quite a lot. It'll be actively fighting to stay on target. Wild ride for sure. And if all that wasn't enough, the lower gravity on Mars changes things too. Yes, less gravity helps land larger payloads there, but that also means falling faster per second from the weaker pull downwards. More on that in a bit. Alright, bottom line is, entering and descending through the Martian atmosphere is going to be extremely dicey compared to Earth. The margin for error is insanely thin. Now, back to more specifics on dealing with the descent. Time to put this all together. After surviving at heart-pounding atmospheric entry, Starship has precious seconds left to wrap up its epic travels and gently touch down. This is where the magic happens. You remember the belly flop, right? Starship's signature move back home for maximum drag. Well, same principle on Mars, except everything happens way faster in the thin air. We're talking snap decision hydraulics firing to flip and reorient while traveling near the speed of sound. With terrain rushing up, Starship must turn engines down at just the right moment to complete the maneuver. Too early could mean burning tons of extra fuel. Too late? No second chances. It has to be perfect. Now, in skydiver position, Starship's landing engines ignite with a crackling roar, blazing out plasma and wheel-balancing hops between boulders. She slows down enough for the final rocket-powered descent, doing a hover slam to stick the landing for good. The leg pistons gently cushion that hundreds of tons mass down. The rocket's cut off right on cue. And after over a half year of black emptiness, at long last, Starship firmly plants human boots in the rust-red regolith of Mars. Okay, final components to make all this work. There cannot be a math error in the fuel calculations. So, how does SpaceX make 100% sure Starship has enough propellant left over to stick the landing? Grab your calculators and follow along. First up, gravity losses. Now, Mars's gravity pulls with a lot less strength, meaning slower acceleration down. Great, right? Well, kinda. That weaker tug also means falling faster each second. So, over the long descent, those velocity losses add up. Next, speed losses themselves, from atmospheric entry to the flip maneuver to the final landing. SpaceX has to offset all that insane horizontal and vertical velocity out of the equation. We already estimated over 700 meters per second needs canceling out. The fuel budget has to account for all undesirable kinetic energy, every last speed bleed. Then, pad an extra chunk as the safety margin. Too little remaining, and Starship becomes a really expensive crater. Oh, and don't forget restrictions on the engines themselves. Raptor performance degrades in Mars's thin carbon dioxide atmosphere. Factoring in those pressures, densities, and chemistry underscores again the foolishness of leaving anything to chance. It's an ultra-complex riddle of calculus and contingency planning. But with enough ground testing, simulation, and likely some overly conservative assumptions, SpaceX can find that sweet spot, the Goldilocks zone of having just enough fuel to ride that Raptor roar down to the surface. Whew. As you can see, what SpaceX is attempting to do here is incredibly difficult. But the potential payoff, enabling the colonization of Mars, makes it well worth the immense engineering challenge. Elon Musk has defied the skeptics before, and while they likely won't nail it on the first few attempts, based on their steady progress so far, I believe SpaceX will stick this crazy landing on Mars within the coming decade. Alright everyone, that wraps up this epic deep dive on Starship's future Mars landings. Let me know what you thought of this format in the comments. And, as always, be sure to like, subscribe, and ring that bell for more juicy space content. This is the Space Technician, signing off for now. And I'll see you, Space Cowboys, in the next one.